You know that sharp, sour taste when you bite into a lemon? Or how soap feels kind of slippery and will taste bitter if you get it in your mouth? That's all chemistry in action. Specifically, it's the chemistry of acids and bases, these powerful substances that are everywhere, all around us and even inside us. And our whole story today starts with a really common problem. Oh, we've all been there. You have a huge meal and then you get that awful, uncomfortable feeling of indigestion. That's your stomach making a little too much acid. So what do? Do you fight fire with fire and drink something acidic, like lemon juice? Or is there a better way? By the time we're done here, you're going to know exactly which one to choose and the cool science that explains why. So here's our game plan. We're going to start with that stomach ache, then get into how we can even tell acids and bases apart. After that, we'll look at the cool reactions they have, figure out how to measure their strength with something called the pH scale, see why that scale is a huge deal in our daily lives, and finally, we'll uncover the hidden power of plain old salt. Okay, so first things first. If we can't, and we definitely should not, go around tasting mystery chemicals, how in the world do we know if something's an acid or a base? Well, scientists have these really clever things called indicators, which basically just change color to give us the answer. The classic tool for this is litmus paper. It's super simple. Here's the rule. An acid will turn blue litmus paper red. A base, on the other hand, does the exact opposite. It turns red litmus paper blue. It's a really quick and reliable test you can do in seconds. And you have totally seen an indicator at work without even knowing it. Turmeric, the spice that makes curry yellow, is a natural indicator. So when you spill some on your shirt and start scrubbing it with soap, which is a base, that yellow stain suddenly turns reddish brown. Yep, your laundry is literally doing a chemistry experiment. Okay, now check this out. Litmus gives us that simple red or blue signal, but there are other indicators, like phenolphthalein, that are a bit more dramatic. It does absolutely nothing in an acid like hydrochloric acid, stays totally clear. But the second you add it to a base like sodium hydroxide, boom, it turns this amazing, vibrant pink. So, different tools for the same job. But what if you can't see a color change? Well, chemistry's got an answer for that too, and this one is all about your nose. They're called olfactory indicators. These are things that change their smell. Take an onion, for instance. It has that super strong, distinct smell, right? But if you mix it with a base, that smell completely vanishes. It's a pretty clever way to figure out what you're dealing with using a totally different sense. All right, so we know how to spot them. Now for the really fun part. Let's dig into what happens when acids and bases actually start reacting with other things. This is where the chemistry gets really exciting. Just picture this classic lab experiment. You take some zinc metal and drop it into acid. Right away, it starts fizzing like crazy, releasing a gas. You then trap that gas in some soap bubbles. And when you bring a lit candle near one of those bubbles, pop! That awesome sharp popping sound is the unmistakable sign of hydrogen gas. And that fantastic pop isn't just for show. It perfectly demonstrates a fundamental rule in chemistry. When an acid reacts with a lot of common metals, it creates two things, a salt and that hydrogen gas that gives us that really satisfying pop. But what about when an acid and a base meet? This is maybe the most important reaction of all. They basically cancel each other out. It's called a neutralization reaction, and it produces a salt and just plain water. And this brings us right back to where we started. That baking soda solution for your indigestion, it's a base. It neutralizes that extra acid in your stomach, and that's what makes you feel better. So yeah, baking soda was the right call all along. So we're getting somewhere. But just knowing something is an acid or a base, that's only half the story. I mean, lemon juice is an acid, and so is the acid in your stomach. But one is way, way stronger than the other. To really get what's going on, we need to be able to measure their strength. And for that, we use the pH scale. It's a scale that usually goes from 0 to 14, and it's all about measuring the concentration, or the power, of hydrogen ions. And that little p in pH? It actually comes from the German word potens, which literally means power. So pH is the power of hydrogen. Pretty cool, right? So here's the breakdown. Anything with a pH below 7 is acidic, and the lower the number, the stronger the acid. Anything above 7 is basic, or what we sometimes call alkaline, and the higher the number, the stronger the base. And right there in the perfect middle, at exactly 7, that's neutral. That's the pH of pure water. Okay, so why should you care about some numbers on a scale? Well, it turns out this pH scale isn't just for a lab. It pretty much governs life itself, from what's happening inside our own bodies to the health of the entire planet. I mean, just get a load of this. Our blood has to stay in this incredibly tiny pH range between 7.0 and 7.8 just for us to stay alive. Our bodies are constantly working to keep that delicate balance. If it shifts even a little bit, our systems would start to fail. It's that critical. And on a bigger scale, when the pH of rain drops below 5.6, that's what we call acid rain. When that acidic water gets into rivers and lakes, it can lower the water's pH so much that it becomes toxic for fish and other aquatic life, throwing entire ecosystems out of whack. And it even affects your smile. After you eat something sugary, the bacteria in your mouth produce acid, which makes the pH in there drop. As soon as it dips below 5.5, your tooth enamel, which is the hardest stuff in your body, actually starts to dissolve. That's why toothpaste are usually basic. They help neutralize that acid and bring the pH back to a safe level. All right, for our final section, we've talked a ton about acids and bases. But what about that other thing that's made when they neutralize each other? Salt. Now, when we hear salt, we all think of the stuff on our dinner table. But in chemistry, salt is a huge family of compounds that have some incredible industrial power. Just listen to this. Simple table salt, sodium chloride, is the starting point, the raw material for a massive number of chemicals that we depend on every single day. It's basically a building block for the whole chemical industry. So how do we do it? One of the most important methods is the chlor-alkali process. It sounds complicated, but the idea is actually pretty simple. You take brine, which is just really salty water, you pass electricity through it, and that current breaks it down into 3 incredibly useful products. And the payoff here is just huge. Think about it. From just salt and water, we get chlorine, which we use to make our drinking water safe. We get hydrogen, which is used for fuels and to make fertilizer. And we get sodium hydroxide, a powerful base that's essential for making soap, paper, and detergents. And to bring this all full circle, things like baking soda, the very stuff we use for indigestion, and washing soda for heavy-duty cleaning, they also start their lives as humble, common salt. That little pinch of salt is the beginning of a massive chemical supply chain. So, from the acid in your stomach to the base in your soap, and the salt that starts it all, this basic chemistry is humming along in the background all the time. It really makes you wonder, right? What other invisible scientific forces are shaping every single moment of your life? The world really is a laboratory, and the more you look, the more amazing stuff you'll find.